Hello everyone. So today's topic is continuity of a function. Continuity of a function at a point. We will discuss this. First of all, let us discuss the definition of the continuity of a function at a given point. The definition says that a function f of x is said to be continuous at a point x is equal to a. The point is the value of x at which we have to check the continuity of the function in its domain if the following three conditions are satisfied. We have to satisfy the three conditions. First condition is that f of a should exist, means that the value of a function at the given point at which we have to check the continuity should exist, or in other words it should be finite. For example, if we have a function f of x is equal to 2x plus 2 and we have to check its continuity at x is equal to 1, then what is the meaning of f of a exist? Means that we have to check the value of the function at this particular point. F of 1, we just have to replace x with 1. So 2 into 1 plus 2, the value of function will be 4. This is finite, so it exists. F of a exists. Second condition is that limit x approaches to a, f of x exists. This doesn't mean that x is equal to a. This means x approaching to a. What is the meaning of approaching? Suppose I am having this point. This is a point, suppose a. X, this is x-axis. X should approach a, whether from the left hand side or from the right hand side. This means that x is approaching towards the a. As x approaches to a, the value of the function should also exist at that particular point as x is approaching, right? If it's approaching from left hand side of that point, a is here. If x is approaches from the left hand side of a, then we say that it will calculate the left hand limit, and if x approaches from the right hand side of a, then it will constitute the right hand limit, right? So if these two values are equal, whether x is approaching to a from the left hand side or from the right hand side, the value of the function should be equal. So we say that the limit exists. This should be satisfied. And third one is that as the limit x approaching to a, f of x should be equal to value of function at that particular point. Means that x is, as x is approaching to a, this is a, as x is approaching to a from whatever the side it is, whether it is approaching from the left hand side or from the right hand side of a, the value of function should also approach to that point, whatever the value of the function at that particular point, right? So let's discuss some examples so that the definition of the continuity at a point should be more clear. Let's move. Suppose we have a function f of x is equal to 3x plus 1 and we have to check its continuity at x is equal to 1. Now, to check the continuity, first of all, we should prove that f of 1 exists. We have to check that whether the function exists or not. First of all, whenever we have the graph of the function, we can easily check that whether it is continuous or not. We just have to look at the graph. This is the graph of the function, this line. This is the graph of the function and it is not breaking at any point. There is no break in this graph. It is moving continuous. So it is a continuous function. If there is any breakage or any jump in the graph, means that there is some breakage, then we say that suppose if there will be a function, this, suppose this is a function and it is coming and at x is equal to minus 6, after that the graph moves this, there is a breakage of the function, so it is not continuous, right? So let us move to our graph. Our function is that f of x is equal to 3x plus 1. First of all, f of 1 should be existing. So, value of the function at x is equal to 1. We have to check. Just simply put x is equal to 1. When we put x is equal to 1, what we will get? 3 into 1 plus 1. Answer is 4. It is finite, so it exists. So, first condition is satisfied. Second condition is that we have to prove that left hand limit equal to right hand limit, or we have to prove that the limit exists. Now, what is the meaning of left hand limit? Means that x is approaching to 1, the point at which we have to check the continuity of the function. Here, this is x is equal to 1. It means that left hand limit means that x is approaching to 1 from the left hand side. From the left hand side of 1. Right, it is moving toward 1 from the left hand side. Now let us see the graph. You can see here, as x is approaching to 1, here the value of the function is also approaching to 4. As x approaching to 1, this is the value of x is approaching to 1, the value of function is also approaching to 4, and it is from the left hand side. So what we will write? Left hand limit x approaches to 1 negative represent that it is approaching from the left hand side. The value of the function is approaching to 4, right? So this is the left hand limit of this graph. Now let us discuss the right hand limit. Now this is the function, we have to find out the right hand limit of this function. Right hand limit means that this x is equal to 1, x is approaching to 1 from the right hand side of a of 1, right? Any point at which we have to check the continuity from the right hand side of that point. Here we have x is equal to 1 as that point at which we have to check the continuity. Let's see. As x is approaching to 1, the value of the function is also approaching to 4. So let's see it once again. As x is approaching to 1, the value of the function is also approaching to 4. So what we can write? As x is approaching to 1 positive means that it is approaching from the right hand side, the value of function is also approaching to 4. So what we conclude, that left hand limit equal to right hand limit, or we can say that limit x approaches to 1, f of x exists, right? So the two conditions are satisfied. Now talking about the third condition. Third condition is that the limit x approaches to 1, f of x should be equal to value of the function at that particular point. Now we have seen that left hand limit and right hand limit of the function is equal to 4, means that as x approaches to 1, whether from the right hand side or from the left hand side, right, the value of function is approaching to 4. From right hand side slowly it moves to 4, and from the left hand side it also slowly moving to 4. So value of limit is 4, and the value of function at f is equal to 1 was also calculated. 3 into 1 plus 1, which is equal to 4. So all the three conditions are satisfied. So we can say that f of x is continuous at x is equal to 1. Clear? Now let us move to the another example for the clarification of the idea. Suppose we are having this graph. The function is f of x is equal to x square. Now first of all we have to check that its continuity at x is equal to 1. Now from the graph you can see that there is no breakage in the graph is continuously moving on, so it is a continuous graph. Now we have to check the continuity of this graph at a particular point x is equal to 1, right? So first of all we have to show that f of 1 should exist. We have to check that f of 1 exists. Let us find the value of f of 1. Just substitute value of 1, value of x is equal to 1 in the given function, it is 1. So this exists. So first condition is satisfied. Second condition is that left hand limit should be equal to right hand limit, or limit should exist. Now left hand limit means that at x is equal to 1, left hand limit means that x is approaching to 1 from the left hand side of 1, from the left hand side of 1. Let's see the graph. What is the graph saying? As x is approaching to 1, you can see that the value of the function, as x is approaching to 1, the value of function is also approaching to 1. The value of the function is also approaching to 1, right? Here y-axis represent the f of x and this is the x-axis. As x is approaching to 1 from the left hand side, the value of function is also approaching to 1. So left hand limit is equal to 1. Now let us check the right hand limit also. Right hand limit means that at x is equal to 1, this is 1, that x is approaching from the right hand side towards x is equal to 1. Y-axis represent the f of x. So let us see, as x is approaching to 1 from the right hand side, the value of function is slowly moving to x 1 also. So we can write down limit x approaches to 1 positive from the right hand side. Let's see one more time, that as x approaching to 1, the value of function is also approaching to 1, so its value is 1. So what we get, that left hand limit is equal to right hand limit, or we can say that limit x approaching to 1 f of x exists, right? And the value of the limit is also equal to 1. So two conditions are satisfied. Now moving toward the third condition. Third condition was that limit x approaches to 1, f of x should be equal to value of the function at that particular point. So whether x is approaching from the left hand side or from the right hand side, the value of function is also approaching to 1. So value of the limit is 1 and the value of the function at that point was also 1. So all the three conditions are satisfied. So we can say that f of x is continuous at x is equal to 1. So this was the whole concept of continuity of a function at a particular point. Hope you guys understand. Thank you so much.